What if I told you that right beneath your feet, there's a massive ball of molten metal spinning at over 1,000 degrees Celsius that's literally keeping you alive right now? And what if that same ball just decided one day to pack its bags and say, "I'm out"? Well, buckle up, because we're about to explore the most catastrophic vacation request in Earth's history. And trust me, you're going to want to stick around for this one, because the consequences are absolutely mind-blowing. Picture this scenario. You wake up tomorrow morning, grab your phone to check the weather, and instead of seeing partly cloudy with a chance of rain, you see magnetic field collapsing, solar radiation incoming, please seek underground shelter immediately. Sounds like something out of a science fiction movie, right? Well, today we're diving deep into what would actually happen if Earth's core decided to take a little break from its job. And spoiler alert, it wouldn't be the relaxing vacation any of us signed up for. Now, before we get into the absolute chaos that would ensue, let's talk about what Earth's core actually does on a daily basis. Think of Earth's core as the ultimate multitasker, like that one friend who somehow manages to work 3 jobs, maintain a social life, and still hit the gym every day. Our planet's core is basically a giant furnace sitting about 4,000 miles beneath our feet, and it's been working overtime for the past 4.5 billion years without so much as a coffee break. The core consists of 2 main parts, and understanding these is crucial to grasping just how screwed we'd be if it stopped working. First, there's the inner core, which is solid iron roughly the size of the moon, spinning independently and generating tremendous amounts of heat through radioactive decay. Then there's the outer core, a layer of liquid iron and nickel that's constantly churning and flowing like the world's most dangerous lava lamp. This churning motion in the outer core creates what scientists call the geodynamo effect, and this is where things get really interesting. As this liquid metal moves around, it generates electrical currents, and these currents create Earth's magnetic field. This magnetic field extends far out into space, forming what we call the magnetosphere, which acts like an invisible shield protecting our planet from deadly solar radiation and cosmic particles. But the core doesn't stop there. It's also responsible for driving the movement of tectonic plates through a process called mantle convection. The heat from the core causes material in the mantle to rise and fall in massive convection currents. And these currents slowly push and pull the continents around like pieces on a giant, very slow chessboard. So now that we understand what our planetary engine actually does, let's imagine it decides to go on strike. The first thing that would happen is probably the most terrifying. Our magnetic field would start to weaken and eventually disappear entirely. Without this protective shield, solar wind and cosmic radiation would start bombarding our atmosphere directly. Within the first few weeks of the core's vacation, sensitive electronic equipment would start malfunctioning as radiation levels increased. Satellites would begin failing one by one, taking out GPS systems, communication networks, and weather monitoring equipment. Your smartphone would become about as useful as a paperweight. And forget about streaming videos or checking social media, because the infrastructure supporting the internet would be getting fried by cosmic rays. But the electronics failing would be just the beginning. As the magnetic field continued to weaken, the upper atmosphere would start getting stripped away by solar wind. This process wouldn't happen overnight, but over months and years, Earth would slowly start losing its atmospheric blanket. The same thing happened to Mars billions of years ago when it lost its magnetic field. And look how that turned out, a cold, barren desert with an atmosphere thinner than a politician's promise. Meanwhile, on the surface, we'd start noticing some pretty dramatic changes in our weather patterns. The core's heat drives many of the convection currents in our oceans and atmosphere. So without that energy source, global circulation patterns would begin to break down. Ocean currents like the Gulf Stream, which keeps Europe relatively warm despite its northern latitude, would start to weaken and potentially shut down entirely. This would trigger rapid climate changes across the globe. Areas that are currently temperate might suddenly find themselves experiencing Arctic conditions, while other regions could see their weather become completely unpredictable. Imagine Florida suddenly getting hit with Siberian winters, while Alaska experiences tropical heat waves. The agricultural implications alone would be devastating, as crops wouldn't be able to adapt to such rapid changes in climate patterns. But wait, there's more chaos to come. Remember those tectonic plates I mentioned earlier? Well, they'd start behaving very differently too. Without the driving force of mantle convection, plate tectonics would gradually slow down and eventually stop. Now, you might think this sounds like good news. No more earthquakes or volcanic eruptions, right? Wrong. The sudden change in tectonic activity would actually trigger massive instability. Existing stress points along fault lines would release suddenly, causing unprecedented earthquakes. Volcanic systems that rely on the steady movement of plates would either shut down abruptly or explode violently as pressure builds up with nowhere to go. The ring of fire around the Pacific would become even more active as the system tries to adjust to its new reality. Speaking of volcanoes, here's where things get really interesting from a physics standpoint. Many active volcanoes are essentially pressure release valves for the immense heat and energy generated by the core. If the core stopped working, this heat would still need to go somewhere, but the normal pathways would be disrupted. This could lead to the formation of entirely new volcanic systems in unexpected places, or cause existing ones to behave in completely unpredictable ways. The geological implications would be staggering. Mountain ranges that have been slowly growing for millions of years would stop their upward march. The Himalayas, which are still getting taller as the Indian plate pushes into the Eurasian plate, would freeze in their current state. Meanwhile, other mountain ranges might actually start collapsing as the forces that have been holding them up disappear. Now, let's talk about what this would mean for life on Earth. The loss of our magnetic field would have immediate consequences for any organisms that rely on Earth's magnetic field for navigation. Migratory animals like birds, sea turtles, and whales would suddenly find themselves completely lost, unable to follow the magnetic highways they've been using for millions of years. This would lead to massive die-offs as these animals couldn't find their breeding grounds, feeding areas, or seasonal habitats. But the radiation exposure would be an even bigger problem for all life forms. Without our magnetic shield, harmful cosmic rays and solar particles would reach the surface in much higher concentrations. This would dramatically increase cancer rates in humans and animals, while also causing genetic mutations that could have unpredictable effects on future generations. Plants would face their own unique challenges. Many species rely on subtle magnetic cues for various biological processes, and the disruption of the magnetic field could interfere with everything from seed germination to flowering cycles. Combined with the rapid climate changes, entire ecosystems would collapse as species fail to adapt quickly enough to the new conditions. The oceans would undergo perhaps the most dramatic changes of all. Ocean circulation is largely driven by temperature differences created by the core's heat, and without this driving force, the massive conveyor belt of currents that distribute heat, and nutrients around the globe would shut down. This would create dead zones in parts of the ocean, while causing others to become superhighways for whatever currents manage to keep flowing. Marine ecosystems that have evolved over millions of years to take advantage of these current patterns would collapse virtually overnight. Fish populations would crash as their food sources disappear or migrate to areas they can't reach. Coral reefs, already stressed by current climate change, would face complete extinction as water temperatures and chemistry change rapidly. From a technological standpoint, humanity would face unprecedented challenges. Our entire modern civilization depends on electronic systems that would be extremely vulnerable to increased radiation. Power grids would become unreliable as solar storms, no longer deflected by our magnetic field, would cause massive blackouts. The International Space Station would become uninhabitable, and any dreams of space exploration would have to be put on hold indefinitely. But here's where human ingenuity might actually shine. Faced with such an existential crisis, we'd probably see the fastest technological advancement in human history. Underground cities would become not just an option, but a necessity, as the surface becomes increasingly hostile to life. We'd need to develop new forms of radiation shielding, completely redesign our electronic systems to be more resistant to cosmic rays, and find ways to artificially recreate the biological cues that life depends on. The economic implications would be staggering. Insurance companies would go bankrupt overnight as they tried to cover the costs of a literally planet-wide disaster. Global supply chains, already fragile, would completely collapse as transportation becomes dangerous and unreliable. The stock market would probably stop existing altogether as the infrastructure supporting modern finance gets fried by radiation. But perhaps most interesting would be the social and political changes. Faced with a truly global threat that affects everyone equally, we might actually see unprecedented levels of international cooperation. When your choices work together or watch civilization collapse, even the most stubborn politicians tend to find common ground pretty quickly. Scientists estimate that if Earth's core actually stopped functioning, we'd have maybe a few thousand years before the planet became completely uninhabitable, assuming we could solve the immediate problems of radiation exposure and electronic infrastructure. That might sound like a long time, but in geological terms, it's barely a blink of an eye. The good news is that Earth's core stopping is incredibly unlikely to happen anytime soon. The processes that drive the core are powered by radioactive decay and leftover heat from the planet's formation, and there's enough fuel to keep this cosmic engine running for billions of years to come. The core is incredibly stable, and even if it did start to slow down, it would happen over such long time scales that life would have plenty of time to adapt. However, studying these hypothetical scenarios isn't just an exercise in scientific imagination. Understanding how Earth's systems are interconnected helps us appreciate just how delicately balanced our planet really is, and how many things need to go right for life as we know it to exist. It also helps us prepare for other potential disasters, both natural and human-made, that could disrupt these critical systems. For instance, scientists are already studying how solar storms and magnetic pole reversals, which do happen naturally, affect our technology and biology. The research into these core vacation scenarios helps inform our preparations for these more realistic, but still potentially devastating events. The more we learn about Earth's inner workings, the more we realize how remarkable it is that we exist at all. Our planet is essentially a perfectly tuned machine with thousands of interconnected systems all working together to maintain the conditions necessary for life. The core, spinning away in the darkness miles beneath our feet, is just one part of this incredible system, but it's a part that makes almost everything else possible. So the next time you're worried about your daily problems, take a moment to appreciate the fact that there's a giant ball of molten metal spinning beneath you at over 1,000 degrees, generating the magnetic field that's keeping you alive, driving the geological processes that created the continents you live on, and powering the systems that make Earth the incredible, life-sustaining planet it is. Because while Earth's core taking a vacation might make for an interesting thought experiment, the reality is that it's been faithfully doing its job for billions of years, and with any luck, it'll keep doing it for billions more. And honestly, given everything we've learned about what would happen if it stopped, I think we can all agree that's probably for the best.